In this problem, we've got a cubical dice, and it's biased, meaning it's not fair, so the probability of an odd number is 3 times the probability of an even number. And they want us to find the distribution for the scores. So, this is not a fair dice. The probabilities are not going to be 1, 6, 1, 6, 1, 6, 1, 6, 1, 6. So, we got to figure this out. Now, the probability of x is equal to, and it's different. So, let's call it k. All right, so let's say that the probability is sometimes equal to k. Now, what numbers would they be equal to k? Well, let's just say it's going to be 2, 4, and 6. All right? Now, the other numbers are going to be 3 times k, the odd numbers. So what happens is, in this situation, the probabilities have a rule. It's kind of like a piecewise function. So if I set up my probability distribution, I've got 1, 2, 3, 4, 5, and 6 as possibilities. And now I got to figure out the probabilities for each one of these. Well, all I can do is deal with the k's for right now. If it's a 2 or a 4 or a 6, I'm saying it's going to equal k. So now what I want you to do is pause the video and, using the rule we have up ahead, see if you can figure out what it would be for the 1, 3, and 5. Start it back up when you're ready. All right, hopefully you did that. I've got 3k, 3k, and 3k because it's 3 times the other ones, right? Now, keep in mind, all the probabilities must add up to 1. So take a second, pause it, and figure out what k should equal. Great, hopefully you did that. I've got, 12 k's are equal to 1. K's got to equal 1/12. Now, to write a probability distribution, what I've got to do now is replace those k's with what it's equal to. So, for example, if it's a 1, that probability is actually going to be 3/12. So now, pause it, and then see if you can't fill in the rest of the probabilities for our probability distribution. Start it back up when you're ready. All right, hopefully you did that. I got 1/12, 3/12, 1/12, 3/12, and 1/12. And keep in mind, the rule about reducing fractions, at least as far as probability distributions go, we can leave them unreduced. That way we can quickly check and see if they add up to 1.